All right, good afternoon, everyone. Welcome to the StorTrends Virtual Lunch and Learn. My name is Tyler Newberry. I'll be your host and moderator for today's event. Along with me today, we have our Senior Solutions Engineer, James Dykowski, to walk us through this wonderful world of storage. As you can see, his handsome mug up there on the screen for you right now. He'll be joining us in just a moment, but just wanted to go over a few quick things about the event today, just so that you'll kind of know what to expect and all of that good stuff. So first of all, if you are in a pizza delivery zone and you requested a pizza, that should be arriving shortly if it hasn't already. Sometimes the delivery people will take a little, they'll be a little slow. They'll take a little while to actually get to your office. So please be patient with them. We ask that if you don't receive your pizza or a call from the delivery company by 12:10 p.m. Pacific time or so, then give us a call or shoot me an email at tylern@ami.com. You can see my email up there. Like I said, that's a little bit easier than trying to go through the Q&A communicator. So yeah, that's the way to get in communications if you haven't had your pizza, like I said, by 12:10 or 12:15 or so. Number two, during the presentation, please ask questions. We want this to be as much of an interactive event as possible, and we want this to be tailored as much to your needs as it is to what we're trying to tell you about with different StorTrends products and offerings and stuff. So like I said, please ask questions. There's a Q&A communicator at the bottom right-hand corner of your screen, so feel free to shoot that over to us. Looks like some of you have already figured out how to use it. That's absolutely perfect. And last and certainly not least, if we do have any technical difficulties today, occasionally WebEx will give us a hiccup or two. They are fairly rare, but they do occur, so we want to make sure that everyone knows that it could happen. So if the screen goes grainy for a second, or if we kind of chip in and out of audio, just please bear with us. These problems usually resolve themselves within 30 seconds to a minute or so. So, like I said, if you have any questions or anything about that, feel free to let us know. But other than that, we're ready to get started with this presentation. We've got a great one for you today. We've got our Senior Solutions Engineer, James Dykowski, with us, kind of doing a full overview of storage, all the different technologies that are out there. And hopefully it's a lot of things that you guys are hoping to learn more about and things that you're looking at exploring for your own environment. But without any further ado, I'll go ahead and introduce our Senior Solutions Engineer, Mr. James Dykowski. James, they're all yours.
Hey, thanks, Tyler. Yeah, so what we're going to do is kind of go through our technology and other technologies out there and kind of show, really where we fit in and where just kind of everybody kind of goes together to really, get a good infrastructure together for that makes sense for everybody and not just, kind of going out there with whatever we're selling today or whatever, even understanding what, whatever anybody else is selling and, what the advantages are for doing those and stuff like that. With that, American Megatrends, we are right at 30 years. 1985 we were founded. We started out, making motherboards and developed the BIOS for Michael Dell Incorporated. So we've grown with them over the last 30 years. Obviously, neither company's gone anywhere. And we do have a worldwide presence. There is a lot out in the Pacific side of things. And, of course, we have our offices here in the U.S. and AMI Germany as well, covering that region. There are, somewhere, somehow, our product is in half the computers in the world, at least. So if it's not between you can see the AMI BIOS up top, the Apptio Beyond BIOS, little Intel, remote access controllers we OEM out to many companies, and then of course you can see the LSI Avago logo up top. So the story with that, and the products we have here, our division is StorTrends. We are a stand product. We have dual controllers, and we'll show that in a second. And with that, we took this this LSI product. We actually built that from ground up from 1996, and then sold it off to them in 2001. Brought that team back and developed this product line. Obviously, RAID is a huge function within SAN. If you guys don't know that, well, call me up and I can talk to you about RAID all day long when it comes to how that protects data and how important it is on a block-based SAN solution. So with that, we brought that team back, and now we have StorTrends. You can see we have a lot of IPs, just being about 8 years out into the market. So we have over 114 patents, and actually we're probably about 115 or 150 if you look at what's actually to be granted and stuff like that. Obviously it takes years to get granted patents. And we have a lot of installations, between the OEM side, of which we were just following our company structure before, for now we are actually going out on the channel and talking to you guys. So, again, reach out with any questions, though. It is really, my mom doesn't even want to hear me for an hour speak straight. So, definitely come up with questions, what have you, Tyler, interject, and throw them at me, and we can kind of just make sure that everybody's in the same understanding as we go through this. With the StorTrends, so you can see here, we have all of our, this is our dual controller product line, and we go from just all spinning disk solutions, 15K fast or 7K if you need capacity, up to, a hybrid array, which is our 3500, so it has just a splash of SSDs, of which we utilize for caching and tiering together. And we, we're not going to talk about it here, but we do this to basically kind of manage data as intelligently as possible. Geez, I can't speak today. To basically manage kind of hot data and historically accessed data versus that randomly accessed data that comes in. And then we have our all-flash arrays, the 3600 and 3610, of which these are utilizing dedupe compression and, of course, all-flash technology to really get a good value for the end user for you guys.
Hey, James, let me just hop in right here before you go to this next slide. Just one thing I wanted to point out is, and kind of ask you about, is I noticed on there that 3 of the 4 main products are flash-based solutions. We got the hybrid, and then we have the 2 types of all-flash arrays. Why is it that there is a still an all-spinning disk model there? Is that because there's still a huge market for spinning disk, or do we use that in some sort of DR play? How does that typically work?
Yeah, so of course, some competitors, especially if they don't support all-spinning disks, are going to say disk is dead. Disk is not dead. They probably also, at least the disk vendor, all disk vendors, were going to say tape was dead 10 years ago. And I still know plenty of people with tape. So no, it's absolutely, there are particular value adds for it. There are particular installations that do just require more throughput, more capacity, and that's why you do still provide, all spinning disk solutions.
Very good. Thanks for the explanation.
You got it. Anytime, Tyler.
Oh, man, you're a nice guy.
All right. So here's latency. So we talk about latency, and it's, what is latency? So, of course, you guys probably have heard of it, maybe. Maybe some of you know, hey, latency, yeah, I get good latency, whatever. So here you can see just kind of different levels of latency. Those of you with all-flash arrays or, specific environments to where you do have heavy reads and you do only have, consumer-grade SSDs and stuff like that. Thank you very much. You're looking at sub 5 milliseconds. You're good, fast, snappy, everything's happy. Now, and you're the guy with the sunglasses up there. Now, oopsie, I hit the wrong button. So if you go into the 5 to 20 millisecond, this is probably where most of everybody's at if they're looking at a new deployment of all-flash and they're stepping that infrastructure up. This 5 to 20 milliseconds, so when you look at spinning drives, a standard 15K spinning drive, which is the faster of the spinning drives, you're looking at about 7 milliseconds worth of latency. Now, that's at full load, and now as you go down with I/O, so at full load is 300 IOPS, I would say, for that. Now, we can talk about that stuff too. So literally any numbers that I say out there, I can show you, prove it, whatever you want to say there, and we can do all these things offline or during the call if it's really time permitted. But anyway, so you're looking at 7 milliseconds for that. And then if you go up to 7K drives, you're looking at 14 milliseconds at full load. Now, as you decrease the spinning drives, you're really never going to get below 5 milliseconds. With the 15K drives, you're really never going to get below 2 milliseconds unless you have literally one I/O going across from your initiator, which is just, that's not standard. Now, under peak load, when you do have, hey, I have this database that runs, or hey, I'm doing my backup jobs and stuff like that, your latency may actually get into this orange area, the 20 to 50 milliseconds. And then, of course, going beyond that, it's almost unbearable when you start getting past that. Some people just deal with it, or they're quote-unquote used to it, all that stuff, but getting over 50 milliseconds, it's horrible for your environment. And it's painful when you are trying to get these processes completed, whatever task you are trying to do. And then we have the black hole, the 800 milliseconds there. hopefully you won't be crying like this guy, but it's not a good situation to be in. And, you know, what will happen is if you frequently get 800 milliseconds or more with VMware, it'll start freezing the data store and stuff like that. If you get to 5 seconds, it'll actually just cut off the data store altogether. So obviously you don't want to be there, but that's just kind of where the thresholds are with latency, and then, you know, where you would see your spinning disk at. Did you have a question?
Yeah, we did. So, you know, on everyone's registration, obviously there was an opportunity to fill out, you know, what are you looking for technology-wise? What questions do you have? So one of the questions that kind of repeatedly came up was, you know, hybrid versus all-flash. You know, what are the main differences there? So I wanted to kind of pepper that throughout the presentation today. And so I'll start with, you know, latency, since this is the hot topic right now. And, you know, we'll kind of do like a hybrid versus full-flash thing. But so with hybrid versus full-flash, is there a difference in latency? I mean, is that one of the points that are different between those two technologies? Do you see a difference in latency?
Absolutely. So if you go into hybrid, obviously you're having partial 7K drives and then your partial SSDs. Now, as long as your hybrid vendor is paying attention to what the heavily accessed data is in your environment, and that stays in SSDs, the access data is all you have to worry about. Now, that's going to get sub 1 millisecond. Now, if you calculate it in misses, and in our case, we try to compensate that with a huge cache amount by utilizing SSDs as caching. So we just do a guaranteed buffer of 3 milliseconds for hybrid solutions. But then, of course, all flash, sub 1 millisecond, you're looking at high performance throughout the array. It doesn't matter where the data resides. So in that regard, that's kind of how they compare. And then with the hybrid array, so we focus on 100,000 IOPS. Probably 95% of you guys that we're talking to aren't over 100,000 IOPS. You might be close or, you know, peaking out at 100,000, stuff like that. What does it take to get there? So if you have just simply 4 SSDs, we can get to 100,000 IOPS. I mean, that is amazing when you compare it to what spinning drives required to get there. 285 15K drives, 410K, or 500 7K RPM drives. Now, you may think, oh, what a marketing, you know, bunch of garbage that he's throwing up at me. Who's going to spin 500 drives together? I have customers. I can show you all day to where I've actually seen this in the real world. People are doing this. So you do have to be aware of, you know, the level of efficiency that you're getting with SSDs and the gravity of that. I mean, that was nearly two racks full of shells to strike those disks together. So it's a very inefficient solution when you look at that. Now, if we go into how this affects latency, 1 millisecond with SSDs, at the same 100,000 I/O load, though, even though you have 285 disks, with the 15K drives, you're looking at 7.5 milliseconds. You're looking at 15 milliseconds with the 7K drives at that load, but they can handle that load. And what will happen is, say you do hit 105,000 IOPS or something, and you start going above that or trying to, all that's going to happen is your latency is going to start increasing, and that's where you start getting that over 20, over 50 milliseconds, because your queue depth from the initiator is backing up, or from the OS, I should say. It's backing up, and that's taking time now to fill those because you can only do so much on the front end. So that's where that kind of fits in and how that works. Now, if we're talking about all flash, we have to use something to really maximize that space, because obviously the dollar per gig on individual enterprise SAS drives or SSDs are very expensive. These are some numbers from Permabit. You can see here they expect about 44 zettabytes worth of data in the world by 2020. Obviously, it's estimation, as there's a huge exponential increase there. And you can see, I mean, they're basing it from 2007 here going up. But even if you zoom backward, kind of like the Dow Jones Industrial Average, you can see, I mean, it's all perspective. This growth is the same growth that it looked like from 2013 going back another 15 years. So it is absolutely growing at a tremendous rate. You know, who knows how many copies of my photos, you know, the iPhone has and stuff like that, and how many copies Apple just has around the world. So there is a lot of duplicate data, 75% they show here. Obviously, you need to reduce that if it is just duplicate data that's increasing at this exponential rate. So dedupe is way common stream. That seems all
common
wrong.
Stream? I don't think so.
That sounds all weird.
Commonplace?
Commonplace we should go with. Jeez almighty.
Good enough.
Anyhow, it's everywhere. Windows is releasing dedupe in their NTFS. There's a lot of other vendors obviously pushing with SSDs and going with deduping compression, or I should say compression. So what are we doing here, and why do we say that this is the most efficient? So you can see here, inline deduplication and compression. First of all, you always want it inline because now you're getting the same performance no matter what time of day it is, no matter what the status of, oh, you know, I'm doing more of a workload today or whatnot. So if they go out of band, basically, out of line here, what they're doing is they're going to go ahead and write that down to disk. Well, you're writing this down to all flash. These are SSDs. They have a limited amount of endurance for them. So you cannot just write all this data down. Then down the road, if you have the available moment of downtime, basically read that data back and then dedupe and or compress it, what have you, whatever they're doing, and then rewrite it back down to disk. That's ridiculous. Endurance is a huge factor with these SSDs, a lot of costs associated with them. Now, what we are doing, we're always in line. You're always getting consistent performance. B, we're deduping first. So of compressed data, dedupe is substantially worse, if even anything, unless you had the exact same file, or we'll say VMs or files, which at some level they are, unless you have the exact same one and nothing is different about them at all. Even, I mean, you can't rename the system name, anything within there. It has to be the exact same file to get dedupe out of compressed data. Now, by doing that, we get a heck of a lot more dedupe out of this. Our dedupe rate is exponentially higher than working on compressed data. We keep our hash table in that regard. Then we compress the data. Now, the problem with compressing the data beforehand, also, not only do you get a poorer dedupe rate, but there's wasted CPU and memory cycles on compressing that data. If it's a duplicate data, why waste it compressing and deduping, or compressing it at all, wasting the resources to do that. So anyway, huge notes on exactly why we do those three things in that order. The performance increase, tremendous, because we're basically always deduping ahead of time. We're not wasting that time compressing. And then the endurance increase, because we're not rewriting data all the time and all that stuff. And then, you know, in general, to really get good value out of the all-flash array, and why we go to the hybrid array, is because this 3-to-1 ratio. So if you get a 3 or better ratio to 1, you can then see value in those SSDs at $1 per gig level. So there's a huge cost savings, but that's why we do support the hybrid array as well for the customers that they don't necessarily have that.
Very good, very good. And another question we had come in on the registration was with regards to deduplicating and compressing at the application level. I know that's something that's getting a lot more popular in the market today, and there's a lot more vendors, like you mentioned Windows earlier, that are, you know, deduping and compressing at the application level. I mean, do you think that that's going to, at some point, eliminate the need for, you know, dedupe compression on the SAN, or do you believe that, you know, the SAN technology is so much better that there will always be a need and there will always be data out there that can be deduped and compressed?
Let me tell you, Tyler. No, I'm kidding. It's more efficient on the SAN side. This is what we're living off of. The application side, they're doing their pieces, and you want to do that well, right? So with this, we are way more efficient than the application is, and I can actually show you that. So the application has insight into the file system. They are looking at every block, sort of, but really they just have that file system up top there, and then they're kind of going as ad hoc there. With us being able to look at every block in the environment, including your snapshot blocks, because even those can be, there can be redundant data in there, because we have access to all that data, we get an even more increase. So it's not only that we are doing it better, we've definitely compared the results of other vendors and also, you know, say NCFS, something like that, at that level, but even so, we can get more data together, of which more data is going to be better dedupe all around. If we look at inline dedupe and compression at different application levels, so he is kind of given a good segue in here. So if we look at the raw data, which is the first screen, the blue is just compression alone, the red is just deduplication alone, and then you can see when we combine these two technologies, how we're really squeezing as much as possible out of this information. You'll see backups. Now, this is just an instance because on an all-flash array, you're not really going to use this as a backup machine. But it's there, and it's a realistic number, so we do want to show kind of the baseline. That's the high-end baseline. Now, if you start going into virtual servers desktops, 33 to 1, this would be all of the same replicas, and then your link clone spinning off of that, so that'd be a very good environment. But in general, you are going to see a higher rate with a VDI environment. And then here you can see database environment with workflow is the key little parentheses there. What workflow means is you have duplicate databases for, say, like a reporting server, or say your application spins off a passive database for each individual user to run off of, and stuff like that. If those are designed that way, you have a lot of duplicate data, and you'll get a good rate. A 15 to 1, 10 to 1, those are very common numbers for that. Now, if you don't have the workflow, if you don't make multiple copies, if you're an MSP provider, stuff like that, to where you're just housing databases for individual companies, those are all going to be very specific databases. There's not going to be any duplicate data at all in there. You're going to be looking at a 1-to-1 ratio outside for duplication. So now 2 to 1, though, you're definitely going to get out of compression on just a standard database, and we'll talk about that here in a second. And now you can see the Exchange environment. So there's this great story, and it's a perfect example of what I was talking about before with how we do it better. The Exchange environment, you can see the 9 to 1. So if you have 10 terabytes, you're looking at about 1.1 terabytes at the end of the day. Well, in this example, we actually had a 10 terabyte database. It was one of our customers. They had Exchange compression on. That went down to 6 terabytes. They stored it on our unit. That ended up being 3 terabytes of used capacity. Well, they were saying, hey, 6 terabytes is what you got, and 3 terabytes is what you are storing. That's a 2-to-1 ratio. I thought I was getting a 9-to-1 ratio. Digging in, found out compression was enabled on Exchange, decompressed the database, and then re-put it on our StorTrends unit. That turned into 1 terabyte. So you really can see how what we're doing is so much more efficient when we're looking at the block level and stuff like that. User directories, the 2-to-1 ratio. So what is 2 to 1? That's horrible. And you know what? I have a lot of user directories. This is why we have a hybrid array. Okay, so user directories, what are they compiled of? A lot of compressed data. Excel, PowerPoint, Microsoft Office compresses all of this data. Compressed data gives a very poor dedupe rate. So overall, you're going to get a 2-to-1 ratio out of that data. And ironically, what was that Exchange environment? 6 terabytes to 3 terabytes. That was a 2-to-1 ratio because it was compressed data. So it's the exact same example, just because we're just looking at the blocks. It doesn't matter what's on top of it outside of the way that actual architecture is, what kind of data it really is. So anyways, that's kind of how this really applies into these individual solutions. And of course, you know, a lot of guys have a mix of all this stuff, so then we have to kind of calculate based on each individual piece of their infrastructure and then put together, hey, what is the best solution for you? So now, when we do apply this at the kind of the overview level, how does this fit into the actual storage? So here we'll kind of go, this is a hybrid solution. You have your multiple tiers. Our default is 2 tiers. We support up to 8 tiers, so it's more complex than it could be, but we didn't want to make it too simple either. So you can see the tier 0. We do have the light red and the dark red. That's because we have caching and tiering. We don't duplicate any blocks in our SSDs, but we kind of mix those together. So anyways, you can see replicas up there for a VDI environment. Well, that's where all your link clones spin off of. Very important to have high performance for that data. Temp OS space, these are each individual desktop thinking that they're their own actual physical machine. Their OS is doing updates and stuff like that. And then if you have persistent users, you want them to have kind of higher end space, but not that, 7K drive space. You could have a tier 1 drive pinning for those. And so anyways, the point is we can pin the volumes to whichever specific workload that you need them to be and really make this thing efficient. If you didn't want to do that and you had just, hey, you know what, I have this one volume, this one's for this template, this volume's for that template, and I just want the OS to do what it does, or the StorTrends to do what it does, we can just simply do that. And we do watch the blocks at that level of how many accesses they have and how to go forward with that. Now, obviously, with an all-flash environment, this makes everything just easier. You have all your volumes. They all have all-flash space. There's no question about it. What your performance is going to be say you wanted to mount a snapshot and actually, check something, maybe test your updates or stuff like that. Or if you wanted to deploy a new golden image without, say you're not on VMware and you don't have the ability to use VAI, you want that to be as fast as possible, so you have that available right there. Now, if you look at databases, you can see here I have this SSD tier layer and the spinning disk tier layer. It is a tier, though. So anyways, literally, your databases are segmented like this. It might be a little more than others on the back-end space and how much access there is, but there is just a layer that's heavily accessed in your database when it comes to I/O, and we'll talk about that actually. So here, similar situation though. You can pin individual volumes to individual tiers and say, hey, I don't want indices to ever exceed my 15K tier. I don't ever want my snapshots on tier 2, or on tier 0 or tier 1. And then, you know what, I want my database though pinned up in the SSDs. You can do all these things with the hybrid array. Of course, with an all-flash array, it's one tier, you're good to go in that regard. And then the biggest piece here is really looking at backups. So this has actually been our bread and butter for years. So we can always take a StorTrends unit, replicate it to another, and hey, everybody else does that. So if you've heard of Riverbed or Silver Peak WAN optimization technology, we actually have that built into our own stack, into our own replication with the snapshots and everything. So we are optimizing that link to the T. If you're replicating data, you can't get a web page through there as long as you have it throttled to 100% of the link. You compress, dedupe the data to reduce the amount of data sent. Your RPO, RTO, everything is absolutely increased to the end with stand-to-stand replication with the way that we do things. And, one thing to note, we do provide free POCs, so if you don't believe what I'm saying, if you don't want to ask Tyler, but we give free POCs out there to actually say, this is what we do, this is how we do it well, here you go, test it for yourself. So with this, so say it's an active-active site. I know we have site A and DR site, but say you have active-active. On that DR site, you're also hosting other data. So how does a hybrid solution fit in there? Well, you can pin your volumes, you can pin your DR space down, so now you can kind of optimize this. None of your DR space is wasting any caching, any SSD space tier on the tier or anything like that. Now that's nice, fun and dandy. What happens when you fail over though? This is where some people are like, nah, I need that high-end performance over there. Okay, well that's fine. You can also buy an all-flash array for the DR side as well. We love selling disks, so the higher end disks we sell, the more money we make. It's fine. We provide the availability for you to do whatever you need to do, though. So in this case, if you did fail over, you don't have to worry about, okay, well, I failed over, so now my DR space is at the low tier. I have to wait for it to promote. We do provide caching to try to make that faster. However, it takes time to where, in this case, with an all-flash array, you're up in all-flash as we go. So obviously, there is a huge note there, and there's a break in between the hybrid and all-flash array. Now, if you wanted, say you had a hybrid as a primary and you just wanted to keep the data safe, absolutely, that all-spinning disk unit, we can put that down there. We don't care. We don't require specific units on each side. Did you have a question?
Yeah, actually, and this is kind of one that came in.
Yeah, he's looking at me weird, so I know he's about to ask a question.
Yeah, it's always weird. It's always weird trying to interrupt during a live broadcast. But and this kind of came in, with regards to the lifespan of disk drives, and I guess kind of the old wives' tale or the old thought process with SSDs was that they were a little bit less reliable than the spinning disk drives in terms of how long they last and their failure rates, burnout rates, et cetera. So we just had a question come in, and just kind of wanted you to comment on, how SSDs do in terms of lifespan nowadays, and kind of what their reliability is compared to spinning disks.
Yeah, so there's a few notes on that. So the first thing, I can't wait to see once some of these all-flash vendors that are our competitors get 5 years old, and they start seeing these drives drop, particularly the ones that are selling consumer-grade drives. There is a huge difference between enterprise-grade drives and consumer-grade. Enterprise-grade, you can overwrite the drive 10 to 20 times a day for 5 years straight and be fine on endurance. And that's like 70-something petabytes worth of data that you can write to one individual drive. Now, for the consumer-grade drive, that's a fifth of the space. So it's not even remotely close to the same capabilities as the enterprise-class drive. And, of course, they're selling them for a premium, which is ridiculous, and they're selling them just a little bit of discount, to the enterprise class when they are, 300 times less valuable when it comes to the endurance and the life of these drives. That being said, with our hybrid arrays, we have just a few that are at 99. I think we just had a customer hit 98% of the endurance on their SSD drive. That's after 2 years of I/O. They've been as a primary. So the way that we're writing to the drives, everything that we're doing from our RAID layer, because obviously this is a RAID team, they've really worked hard on writing to these drives as efficiently as possible. And the way that we do this is always, the invention of our company basically is to make sure, we're not inventing technology necessarily. We're doing it our own way and trying to make it as efficient as possible for the end user. Did I miss something? No, we're good?
I think you nailed it.
So how do we know what I'm saying is not a bunch of just bull honky, I guess we should say. Southern way of calling it, right? So we have the StorTrends iData tool, similar to Dell DPAC, stuff like that, to where you just download it from our website. It's absolutely free. You can see here you can either download the dedupe analyzer, which will just basically tell you on a Windows machine how much your dedupe is for a particular database or something like that. Now, we also have the iData tool, which this basically will get installed to the whole infrastructure. And so you put it on one utility server. You plug in your IPs right here. Right here you can do a discovery so that you can just select whatever IPs. Or you can just put in your IPs here, Windows, VMware. If you have a vCenter server, you just put in your vCenter server IP. It'll basically auto-log into all your hosts for you, and then put in username, password. And what it'll do is basically start running through the environment. We'd like it to run for 7 days to get a full week's worth, and by doing that, we get this little PDF report back. So we'll get the iData file from you. We'll then have an engineer review it, run it through what we call PDG, and they'll send you a PDF with all of your environmental information as an overview, which you can see here, and then each individual host as well. If there is virtualization in there, it'll dig down to each individual VM and all that stuff. So it really digs in deep to what's available. Here you can kind of see while it's running, you can just kind of see CPU utilization, memory utilization, and then, what device do you have here? So you can see this is a VMware ESX host, this is a Hyper-V host, all that kind of stuff in this one screen. You can, use it for Exchange SQL. One thing that came after the fact is actually using it for desktop profiling for VDI environments. So another thing that you could kind of utilize this for, give it to, Susan in accounting, give it to Tyler, give it to whoever in marketing, and kind of get profiles for each individual type of user that you have. And so, of course, it'll give you IOPS, throughput, all these up-in-the-air questions. Hey, what does my latency look like? I don't even know. I have no way of finding out. You can basically simply find this out right here. And it's absolutely free. Swear to you, we don't charge a dime for it. So now, what does this tell us? So for infrastructure, so these are people with, I got my Exchange, I got some SQL, I got a couple of file shares. How much data are you accessing, and how much SSD space do you really need? And this is where hybrids really kick in here, because look how much data is really unaccessed in an environment. You're looking at, 60 to 70% with an exception, and there's a specific reason for this exception with this company, but these are our actual customers, and these are their actual data and access patterns. So here, over a week, unaccessed at all, this is why you have hybrid arrays. Now, to have 30% of your environment in an SSD environment, that's a little ridiculous. So you're not really going to do that, just because, say this is 50 terabytes, 10% is 5 terabytes. 5 terabytes worth of flash, or going up to 15 terabytes worth of flash, it's a lot of space. So how much really SSD do you need? I was actually initially doing this to debunk what all the other competitors saying, oh, 10% is a good rough number. It's, simple. You just do 10% flash space and you're covered. Well, it actually is a pretty good number, as it turns out. So here you can see the 10%. You can see the bright red, which is access within an hour. Most likely this is this yellow 100-plus accesses. Most likely some of this right here was yellow an hour within the last day or so, right? So it was heavier access at one point in time. It was new, fresh data. And here you can see kind of just what's accessed within a day, which, of course, all this stuff rolls out. So now this is access, or I'm sorry, this is yellow stuff from some point within the day. This is bright red stuff from some point in the last 3 or 4 days. And so that's kind of how this migration and manage rolls. So as long as you're monitoring this data and doing what you need to in the background, which we do, then you're good to go with the hybrid array, no problem at all. Now, there are some customers, you have a month-end report that it accesses everything, and as it turns out, this report was run, the iData was run at that point in time. It is what it is, but, you know, hey, it was data access. We have to be aware of that. So this is kind of how we see this. Now, what if you get more specific and get into just database environments? And I told you we're going to look at how that stripe, that SSD tier layer really is a stripe there. In comparison, so you're looking at percentages here. So we're trying to get these on a level playing ground. The infrastructure versus the databases are a lot more efficient when it comes to actual heavy I/O and where these I/Os come from. So these 100 plus, and I just use 100 plus because it's 100 accesses within an hour. It's accessed, you know, and even smaller percentage of that is 1,000 or 10,000 accesses. But you can kind of see how much access by data you're really looking at. And so you can see here, actually, they're a lot more efficient when it comes to overall just access space within a day, and then, of course, access space within an hour. You can get away with half the SSD space because it is a very specific solution, and, you know, databases are just more efficient overall. So now if we overlay them, like we kind of talked about before, you know, you're looking at 3 terabytes if you want to cover that space, 12 terabytes if you want to cover, you know, the day worth of space. You know, 12 terabytes is quite a bit of SSD space, especially if you focus on enterprise-class SSD drives. But, hey, you know what? That's what compression and dedupe, that's where that really fits in. So now you're reducing that data down. If you get a 3-to-1, that's down to 4 terabytes. You can get a day worth of data basically into 4 terabytes, as opposed to the hybrid solution, which it does have it all expanded out. But there's a reason for that. There's so much of an overhead with compression and dedupe. Those spinning drives would get hammered with dedupe and compression to where the all-flash array, we don't have to worry about that because we do have that available. So that's kind of how the two solutions fit together. And then the 10% actually turns into enterprise-class space for our all-flash solution, and then we utilize consumer-grade drives for basically the read-only or the unaccessed data. So we're kind of mixing both of those together. And why do we do that? Okay, so first of all, our data intelligence, we're watching reads and writes coming into the system. We're historically watching how many times these blocks are all accessed individually. So if it's 50 terabytes, we're watching all 50 terabytes worth of data and saying, oh, you know, this block right here, right in the middle of the 50 terabytes, that's accessed 1,000 times. Oh, this one's accessed 500 times. We know these kinds of values, and then how old they are actually. And so, of course, so now if we're watching read and write data, why would we ever worry about read data on enterprise-class drives when, you know what, actually they can run for 2,000 plus years straight is the spec, and of course they haven't tested it, but 2,000 years straight if they're just on or getting read from. There's no wear on the cells physically when they're read from. Now, when they're written to, that's where the wear comes in, and that's why they can only be limited, or they are limited to their endurance, quote unquote. So what we do is say, hey, let's mix these two technologies together and maximize the dollar per gig, because consumer-grade drives, they're substantially less expensive than the enterprise class. Why don't we maximize that? So we automate all of these functions for you, and that's what gives us our value. Now, going a step further, what happens if that Z block gets written to? We have an endless cache algorithm, which we kind of actually stole from the hybrid array because we have read and write caching inside of the SSDs. And so what we'll say is, hey, if that's the write to that tier, that's going straight into our cache, and we'll immediately write it to the SSDs for the enterprise class SSDs. That's very, very huge on endurance and maximizing the data that's accessed within the day. So, of course, everything's endured. And you know what? For all of this environment that we're talking about here, hey, this 30%, you're looking at covering everything in 10%, you can divide it by 3 because of our dedupe ratio, you're getting a day worth of data, and that's even worse. That's assuming all rights. So we're really covering our bases when it comes to what we're doing in that regard. Now, what happens if disk drives fail? We have storage support, of course, available. This is just kind of the overview, 1 to 5 year terms, 24/7, next business day for replacement. And then, of course, you can expand on, we have customers that are over 8 years old. We still support them, so you don't have to worry about those kinds of things. And then here you can see the Storage Plus support, and that's just adding 4-hour on-site when it comes to the overview of what it does. You do receive personalized support. This is from Atlanta, Georgia. That's where I'm headquartered. Our dev team is here. Our QA team is here. All that stuff. So you will be talking to, they may have a little bit of a southern accent. I don't know if you can tell a little bit mine. Sometimes I say y'all, and you can't get that out of you. But, hey, it is what it is. Speaking English 100%. Everybody's an engineer you talk to. There's no middleman there. And then you do have localized presence, and it's not an upcharge or anything. You're talking to people that you have talked to before, unless you're a brand new customer, of course. There's always people trying to get me with things, so I'm going to go ahead and throw in the getcha, or the gotcha. And then you're talking to a pod of engineers, so it may not be the exact same person, but in these pods, you'll talk to somebody, and in general, you get the same person. And then what will happen is you'll have somebody for virtualization, you'll have somebody for databases, somebody for VDI, and they can really help you, depending on what your structure is, what you have there. And of course, it eliminates the dumb questions. Do you have the unit plugged in? Are the network cables plugged in? All these things that I can't, we'll put it like this, I can't stand calling support. I actually had to put in a support ticket for an application I was running earlier, and I'm still waiting on a response back, actually, but it's a side note. Also, email alert monitoring, critical. Obviously, AMI support team, the storage support team monitors email alerts that are critical from your unit. So if you have a drive fail, controller, power supply, whatever, we are going to be aware of that. This is 24/7 fail alert monitoring. We also have proactive drive replacement. So another alert that comes in are critical alerts based on medium errors or endurance thresholds now with SSDs, right? So if our medium errors get up to a certain point on the hybrid array for the spinning drive, we then will go ahead and proactively replace these drives. So you're not worrying about it either on the evening or the weekend. You're not having that problem just basically in the middle of the week, and we're trying to cover abrupt failures. 9 out of 10 spinning drives are replaced ahead of time. And then, of course, automatic replacement, and you rebuild basically on your time. You don't have to worry about it. That being said, we do have an I/O offload engine inside of our arrays to where when we do pull a drive out, or a drive fails, I should say, I'm always in the testing mode because that's usually when we have to do it. You're looking at a 5 to 10% degradation because what we do is we treat these arrays individually, and you'll actually see that in the little demo here. And by treating them individually, we actually offload because we're watching reads and writes. We have tremendous data intelligence insight into all of the data in there. We'll write all the data to other arrays in the infrastructure, and that's where a lot of your overhead comes from. Of course, we have to read from the degraded array. That's where the block resides. It is what it is, but then you get to rebuild faster with a smaller footprint of overhead basically to your frontline I/O. All these units are dual controller, RAIDs, everything's covered when it comes to redundancy, power supplies. These power supplies are agnostic from the controller, so if the power supply fails, it's not like a controller fails or anything like that. And then one thing that's optional, you can buy a fruit kit. You don't have to wait for the guy to come on site and then, oh, hey, I'll put this drive in, I'll just put it in myself. If you're that kind of person, we can basically give you a fruit kit. You don't have to kind of worry about the 4-hour on-site from Storage Plus, but that Plus does come with a fruit kit as well, so you kind of don't have to worry about it either way. And then, of course, status. Debug dumps, they do a yearly check at minimum. You just simply download it locally or download it directly to your personalized FTP site that we provide to you. And then, of course, updates, 0 downtime. You can either update them via FTP and download the patch directly, or you can download the patch ahead of time and then basically update on your time. They're both ways, fails the controllers over, all that kind of stuff. So very seamless when it comes to all those factors. So now, how do we stack up? So here you can see just kind of the performance metrics within Storage Review they actually did a full test of our unit and in comparison to everybody else's units. So here we have, the SQL test on the left side. Average transactions per second, you can see 6,200. This is against our competition, Dot Hill, XIO, HP, Dell EQ, T-Giles down there at the bottom. I wasn't trying to be funny. Time just made me laugh. So anyway, so 6,200 transactions per second. The highest in class right there. And then you can see below that the corresponding latency at that level. We are the absolute lowest. We're under 100 milliseconds at. This is absolute full load when it comes to that. You can see nobody else has been under 100 milliseconds of latency for that 30,000 user test. And then you have the VMware vMark. Say I'm not doing database, I'm doing virtualization. Okay, fine. Here you can see the virtualization benchmarks. And, it goes by tiles, and what it does is each tile is 100 VMs, and so it shows, it gives a score basically based on those VMs, and of course you can see a couple of them didn't make it. They couldn't even initialize 8 tiles or 10 tiles. I'll leave their names out because you can just see it right there. So now when we look at installation, so here you can see just a bunch of different verticals. Just take your pick. There's a bunch of different types of end users in there. Of course, Walgreens is probably our largest customer, but here you can kind of see finance, cities, what have you. Lockheed Martin's pretty big, if you ever heard of them. So they're in there. And then here you can see some actual examples kind of digging in there. 50 terabytes. This is where that Snappy came from. I don't know if you even saw it at the beginning. But so he wanted Snappy storage. So he was actually an addition customer. So he had a spinning drive, and he wanted it just faster. Here you can see it replaced the Dot Hill SAN, and he's just full of SQL, VMs, and databases. Aquatech, they're out of Pittsburgh, and then these guys, just infrastructure. This is kind of that, just that first screen that I showed you of the data usage. About 5,000 IOPS, but just a bunch of different applications all in one centralized solution. And that replaced an old NetApp. The TGI Office Automation on the bottom left, so you can see 45 terabytes. They just wanted it faster. This was actually a repeat customer, and they basically just upgraded everything. They were, at the time, 6 years old, I believe, and they're doing bidirectional replication. They have a great story for replication. It's active-active infrastructure stuff in Brooklyn. Their warehousing and all that kind of inventory stuff in New Jersey. They replicate both ways, and they have just kind of everything going on there. And then UT Dallas, a very specific 70 terabytes, huge consolidation of a bunch of labs going into one centralized storage, and they're doing brain research, a lot of I/O going in and out of this unit, and they do have a little, some random application databases and a little bit of VDI and stuff like that. So yeah, so that is that portion of everything. Were there any questions?
Well, I was about to say there aren't right now, but this would be the time. If you do have any questions based on what you see in the presentation, go ahead and shoot those over to us now, and we should still be able to get to those within the hour. Like I said before, we will conclude promptly here at the top of the hour. We are very respectful of your time, so I want to make sure that we get you out of here at a decent time. So if you do have any questions, just shoot them on over, and we'll address those as James is kind of walking us through this demo.
Yeah, definitely get some questions there. So we just I use Google Chrome. You can use Firefox, Internet Explorer, whatever you'd like. Here you can kind of see the overview view. So here the data reduction rate is 32 to 1. It's a lot of test data, so it's going to be pretty high in that regard, and I'm able to kind of copy data around and stuff like that. Here you can kind of see the physical use space. So we're looking at 15 gigs worth of use space, and what's actually provisioned is 473 gigs. So that's what's actually seen by the OSs versus what's actually stored onto disk. With that, this unit is physically got 4 terabytes, 3.8 terabytes, I should say, and if this deduction rate continued, I should say, it'll go up to 122 terabytes of predicted capacity. Here you can kind of see we pull drives, we do all kinds of things in this, and people want demos of all kinds of things. Here you can see smart information. If we scroll down, you can kind of see performance. We have a lot of test data just running through here. So you can see a lot more reads here, reads, write, and you can kind of see it based on instantaneous versus hourly average. And it's kind of what you look at here. And then here you can kind of see block sizes, if there was a mix and stuff like that. Now, this is for the overall system. If you want to dig into each, there we go. We can go to the volume stats tab right here. It'll show volume map capacity, snapshot capacity, what's consumed. And then if you look into each individual volume, you can kind of see, okay, where's my IO coming from? Here I have a little bit of IO coming from this volume right here. Obviously, I'm running some tests with some applications and stuff like that, so we can kind of see that. And then here you got the individual volume data down here. And then, of course, if you want to see historically, hey, you know, this is a newer volume, but historically, what does this look like down the road? So that's kind of how the statistics, and this has been a huge upgrade with our latest storage stack to really see an insight into performance and what you're looking at. If we go into this hardware right here, there's a few ways to get to hardware, but we always show an actual picture of the unit. So here as it's loading, we actually see the IO load by disks, and so we'll actually see the lines popping up, and you can see those there. And so these yellow are the enterprise class drives, the greens are the consumer grades, and now you can see the actual IO load on them. It's fairly low, obviously. There's not a lot going on. I just showed you the IO there. And network throughput, you can see it by interface. Here I have 8 interfaces, and then here you can kind of see a little blip of information there. And then you can hover over any items. If you want to see the rear view, oh, I have a red mark. Okay, I've pulled interfaces, no big deal. So you can kind of see what that looks like. And I have multiple subnets here, 771, 2, 5, 5, 10, 11. This one was 1010, all that kind of stuff. And then if you do have multiple enclosures, you basically just select those and then go forward. And you actually see the same type picture for every enclosure. New events, so we do full event logging for left and right controllers. So you can see actually left-right controller, previous system shutdown. I actually just upgraded all these drives, so that's why that happened. And here you can kind of see just right control, left control, and all that stuff. Now, with those same events, we can also say, okay, you know, what's the event logging look like with email? So here's the email alert notifications. You enable it, or disable it, like what I just did there. And put in your IP of your email server, whatever your DNS name is, and then, of course, StorTrends alert. If it wasn't a test system, we'd have this enabled. And then, of course, myself, jamesd@ami.com. If you have any questions or you just want to yell at me, email me up, no big deal. And then here you can click to remove or add in, basically, if I wanted to get warning events, no big deal, apply, and I'll get another test alert. If I have my email open, I'll send that over. I'll show you guys here in a second. And then let's see here. So if we go back to the dashboard, there's a couple other things. The update, like I talked about, as well as, what's my alert? There it is. So you can either download it directly to this unit or just simply from a patch, choose file. This is actually on one of my NAS shares on the network. Patch, open, and then basically update. It'll automatically fail everything over, and then basically you're good to go. And here you can see my test email alert. James Lekowski, StorTrends@ami.com, and here 1011-108. Oh, look at that thing. Who would have thought? And so basically this is how the alerts show up in the environment. You actually get that from both controllers, and then you get things like this to where this is from one of my other units in the lab, and to where the disk predictive count is above 0. So this is one of my spinning drives, and basically they're looking at the medium errors, and that's what the alert looks like when you get it in there. This one is a warning. You can see the WARN, no big deal. Basically, that just shows us that it's a warning, so we don't have to really worry about it until it becomes critical. So patch updates, debug dumps, very simply taken as well. You can also do things, like we definitely have customers that they just want it, hey, you know, every 2 weeks, just do an automatic update for each, for our debug dumps. Or some other customers are like, hey, you know what, create an SSH tunnel into our unit so you guys can just get in. No big deal either way, and we can monitor everything remotely in that regard. Just depends on what classified level kind of we're at for that. Storage statistics, this is that same opening screen. Volume stats is that tab right there. And here you can kind of see the control panel. We do have a BMC, so you can just remotely log in directly to the UI through the actual console, I should say. TCP/IP, there's a lot of functionality in here when it comes to networking. Here you can see I have the 8 NICs. We do have our aliases, which are kind of the failovers, and we can also create teams, and we support ALB, transmit load balance, sorry, ALB is adaptive load balance, I should say, 802.3AD, round robin, whatever your flavor is, basically we support that for that. And then here you can kind of see the individual volumes. This is the one we're running IO2 right now, and so what we can actually see is map space is 100 right now. So one of these volumes I haven't accessed in a while, and we should start seeing some demotion in them. I think these are the older ones, actually. Yeah. So now I haven't been accessing it, so now you can see it actually demoting down to the read-intensive drives. I normally, if I wouldn't have just reset this whole test, I normally have a 100% read I/O load, and you can actually see the I/O immediately forcing to Tier 2, which is the consumer-grade drive, because that's where we're not worried about endurance for those drives, and it's heavy read. So we are watching that data, and that's what I like to really prove there in that regard. SRM charting, full everything, and then even our tiering and stuff like that, we are watching the I/O load overall, the system. So we're saying, hey, there's a peak time, we're going to reduce how much background tiering we do, all that kind of stuff we watch. And then you can also set tiering based on policies as well. So if you're like, you know what, I have a very heavy read load, I just want it to go down to there as much as possible, you can then increase or decrease the promotion value. So you can really force things around a lot faster if you want to get more granular, or if you want to get less granular, say, hey, I don't want a lot of movement, you can then change these policies. Same thing with demotion. So that data that's demoting, it hasn't been accessed in over a week, you can basically select this to be whatever you like it to be, it doesn't matter, to really say, hey, this is where we want it to be. Our default values are perfectly fine, though, for everything. So, and then, of course, replication. A lot of functionality in this. Here you can kind of see just an overview of it. You can pause if you want to, schedule snapshots at any individual level, and then here you can kind of see, okay, you know, what selections do we have? I haven't selected anything on here, but I'll just say, you know, we'll do all this stuff. Say we'll do custom settings, so we'll do a gig, fine. And then basically you can also set periodicity based on this and throttle the bandwidth down in the middle of the day, say to 13% Monday through Friday from these hours right here. And then also you can have a default plan and say, you know what, I want this at 90% other than that. Update settings, fine. The peer is just in case you failed over, stuff like that. So now we have these settings in place to where now only 13% in the middle of the day runs, but 87% outside of that does. And you can do multiple levels like this, so you can kind of go down as granular as you'd like. So anyways, we're at 358. You know, there's a lot of other stuff to see in here. I'll kind of run this volume wizard while Tyler takes over. Thank you guys for coming in. Obviously, reach out with any questions, or I don't even know, maybe questions come in. But yeah, what do you got, Tyler?
Yeah, thanks everyone for attending today. We've greatly appreciated presenting to you. One thing to note, we will be posting this event on YouTube. We have been recording this entire event, so that should be up on YouTube tomorrow. I will email everyone the link to that, as well as somewhat of a thank you note for attending and some links if you have any questions. Also, after the event, you'll be redirected to our website from WebEx. So if you want to browse or kind of look around or poke around there, feel free to let us know if you have any questions or need anything like that. There's a price quote generator tool on our website if you're interested in getting a quick quote for one of these types of products. I don't know what caught your interest, if anything, but we can provide a quote on a hybrid and all-flash solution or a spinning disk solution. So just kind of let us know what you're working with. Other than that, I think that's pretty much all we have for you today. James, do you have anything else for the nice people?
No, absolutely not. Thank you very much for coming up and listening to us. And, yeah, hopefully we'll talk to you.
Real quick, one quick question came in. James, is this Oracle supported? I noticed a lot of discussion about SQL or Oracle databases also widely used.
Absolutely. I just use SQL because I feel like 95% of everybody uses it. Obviously, Oracle's more centered around, CRM type situations, but absolutely, yeah. We're at the block level, so we really don't care. As long as it has, an iSCSI initiator, we're good to go when it comes to connectivity, and of course the blocks are actually the same size blocks and all that kind of stuff there. So yeah, that's absolutely no problem whatsoever.
Very good. Well, thanks so much for that explanation, James. We'll go ahead and get out of here. We're going to keep the presentation up, so James will just kind of be going through the demo a little bit further and messing around in the background. We're going to turn audio off, so if anyone wants to stay around and watch James kind of play with the wizard a little bit and watch how he does a few things, you're more than welcome to. We'll keep it up for the next few minutes or so. But again, thanks so much for everybody's attendance, and we look forward to hopefully speaking with you sometime in the future. Thanks so much.